Mr. Carlson here. Let's talk about some oxidation reduction reactions here. Whenever something is going through oxidation, so if something is being oxidized, that means it's losing electrons. And the way we can tell that that's happening is if the oxidation number gets more positive. And if something is being reduced or going through reduction, that means it is gaining electrons and the oxidation number will get more negative. Okay, and we'll do some examples that this will hopefully make a little more sense. But that's what we need to remember. If something's being oxidized, losing electrons. If something's being reduced, it's gaining electrons. A good way to remember that is this little mnemonic device over here. Leo the lion says grr. Leo the lion says grr. So that Leo part there, the L stands for lose, E for electrons, oxidized. So losing electrons means that that thing is oxidized. If something is gaining electrons, it is reduced. So Leo, losing electrons, oxidized, grr, gaining electrons, reduced. It's a good way to remember that when we're looking at these problems. So let's look at a couple examples here. So in this first one, we have this reaction between solid iron and oxygen gas to make iron oxide. So what we're going to have to do is, like in the previous video, we're going to have to assign oxidation numbers in order to figure out what thing is gaining and what thing is losing electrons. So in this, I can see that I've got, at the start here, elemental, not elemental compounds, we have atoms in their elemental state. So I've got iron by itself. And so we learned that in those rules there. And once again, I'm going to use a different color when I do this. So let me come back over here for a second. And we're going to do this. Iron by itself as an element is just going to have an oxidation number of 0. It's going to be neutral. And same thing for oxygen right here. It's all by itself. It's not in a compound with anything else. It's just oxygen. So it's an element by itself. It's 0. And over here, though, I can see that I've got now an ionic compound between iron and oxygen. So oxygen is going to be -2. And for iron, then, in this case, remember if oxygen here is -2, I've got 3 of them. Remember the total then would be -6 coming from those oxygens. What does each iron have to be? Since I've got 2 of them, what does each iron have to be in order to balance out that -6? Each iron would have to be +3, because +3 times 2 would give me a total of +6, and so this would cancel out each other. So therefore, those are what my charges, or my oxidation numbers, have to be for iron and oxygen when they're in that compound. So iron went from 0 to +3. So in order to go from 0 to +3, if we come back up here, that means it had to lose electrons. The oxidation number got more positive, right? It went from 0 to +3. That means it lost electrons. And the thing that is reduced would have to be the oxygen. It gained electrons. It got more negative. And so therefore, iron in this case is the thing that lost electrons, so it is oxidized. And the oxygen in this case is the thing that is reduced, because it's the thing that gained electrons. Gaining electrons reduced. And that's how simple these oxidation reduction reactions are. You're using oxidation numbers, assigning those oxidation numbers to figure out what you have, and then seeing what thing lost electrons, what thing gained electrons, and then you know what is oxidized and what is reduced based on that. So let's try another one. Here we've got solid copper reacting with silver nitrate to make copper nitrate and silver metal. This is a single replacement reaction, what we've got happening here. So let's once again assign our oxidation numbers. So copper's by itself here at the beginning, so it would be 0. In this silver nitrate, now notice what I'm going to do here is I'm not going to assign nitrogen and oxygen separately here. And the reason why is because I have nitrate as an ion on this side. And if I look on the right-hand side, I still have nitrate. So in other words, the nitrogen and the oxygen stay together as that polyatomic ion. And so when I see that, I don't have to assign an oxidation number to nitrogen and oxygen separately. I can just assign an oxidation number to the polyatomic ion itself when I see that. Now, if this were to break up, if I were to notice that that nitrogen and oxygen break apart from each other to form something different, then I would have to do that. But in this case, they stay together as a polyatomic ion, so I don't have to do that. So the nitrate here, I'm going to do this, the nitrate is -1 altogether. So NO3 has a charge of -1, and that means silver is +1. Okay, on the other side, now I've got copper and nitrate together. Now I've got nitrate is still going to be -1, just like it was here, but I've got 2 of them. So the total coming from nitrate is going to be -2, because I've got 2 nitrates, each -1, -2. So that means the copper by itself needs to be +2. And silver over here is now by itself. It was in the compound +1. Now over here it's by itself as just an element on its own, so it is 0. And so once again, let's look at how things change. The copper went from 0 to +2. So it lost electrons, therefore the copper, since it lost electrons, is the thing that is oxidized. And that means the silver, once I can see, by the way, once you see that that is the thing that's oxidized, you automatically know that the other thing must be the thing that's reduced. But we can see from the oxidation numbers as well, it went from +1 to 0. And so in that case, it had to gain an electron in order to get to that 0 charge. And so therefore, it is the thing that is reduced. Last one. POF3 is going to break down or decompose into just PF3 and oxygen gas. So in this case, remember, oxygen and fluorine are always going to be the same charge. So fluorine here, we said, is always -1. Oxygen is always -2. Now the fluorine, I've got 3 of them, so that's a total of -3. So I've got a -2 coming from 1 oxygen. I've got a total of -3 coming from the fluorines. That means that that phosphorus needs to be +5 in this case. So there's my oxidation numbers for the phosphorus, the oxygen, and the fluorine at the beginning. The end here, fluorine, notice in this case, is still going to be the same, -1. Now, again, total is -3 because I have 3 fluorines, each -1. So that means phosphorus in this case, since that oxygen isn't there anymore, is going to be +3 in that case. And then the oxygen is in its elemental state all by itself, so it is 0. So if I look at the fluorine, didn't change. It's going to be -1 on either side, so that's not being oxidized or reduced. But the oxygen went from -2 to 0. So it went from a negative charge, -2, to 0. That means it lost electrons, right? That -2 means it has an extra 2 electrons, and so it had to lose those 2 electrons to get to a 0 charge. So oxygen is the thing that lost electrons, and so it is the thing that is oxidized. Whereas the phosphorus went from +5 to +3, so it gained 2 electrons to get less of a positive charge, basically. So for phosphorus, gained electrons, and it is the thing that is reduced.